So hello, good evening everyone. How are you guys doing? Okay, so first of all, let me welcome you guys to the Unacademy JEE English. Okay, so this, as you know, is a brand new channel by Unacademy, and here every concept of physics, chemistry, and maths are being taught to you completely in English. And this, as you know, is currently the largest online learning platform for IIT JEE. So Unacademy realized that a lot of content available online for JEE preparation was mostly available in English. So that is why Unacademy has brought this new channel where language should not be a barrier for any students learning. That's the aim, and with that aim we have started this channel. And here again we want you to have all sorts of practice. So this is a special session that I host for Olympiad level problems, especially from a book called Pathfinder. So a lot of students had requested me that they wanted me to take problem discussion sessions from this book, as this is one of the toughest books available in the market at right now. And a lot of students are not able to solve this correctly. Okay, so again, why don't we get started with today's discussion? But before we move ahead with the discussion, hello, nothing, peace, how are you? Before we start with today's discussion, let me first introduce myself for those of you who might not know me yet. So my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for IIT JEE Mains Advanced exams, also for KVPY and the Olympiads, by the way. So I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. All right, so this was long time back when the actual final paper would be a subjective paper, and there would be a first stage which would be objective. Yeah. Don't worry, don't worry. Just give it a time. Give it some amount of time. It usually the net actually fluctuates a bit, and then it becomes stable. Don't worry about it. All right. Let's hope it will become fine now. Now, I as a student, I also had qualified the NTSC stage 2, and I was in the top 1% in the NSCP, which is the first stage of the physics Olympiad. Okay. Now, I've already coached many students to top ranks in the JEE exams, both mains and advanced, and I've also successfully coached many students to their KVPY exams and their Olympiads. All right. Now, I hope to continue doing that here with you guys. So how can you guys make sure that you are getting all the content that you need for any kind of examination, be it your JEE, be it your uh, Olympiads, or be it your KVPY? So you can get yourself the Unacademy subscription. This subscription will help you with benefits like live classes where you get to interact with your educators. So here the quantity and the quality of content available is amazing. So trust me, you will be able to prepare for any kind of examination that you're looking to prepare, and with very great ease, right from the comfort of your home, in fact. Now, these classrooms also have live polls and leaderboards, which keep them highly interactive and very efficient. Okay, then you have regular test series and analysis sessions, which is again great while especially preparing for a competitive exam just like JEE. And of course, you have live doubt clearing sessions, so where you can ask away your doubts. So, is it possible to crack JEE in 2 months? Okay, so nothing, peace. First of all, let's talk about your definition of cracking JEE. And I hope you're talking about JEE Mains. JEE Mains, maybe you can do all right in 2 months. I mean, depends. It's a competitive exam, so you realize because it's a competitive exam, so a lot of thing depends on your performance relative to others. It's not like boards. Can in 2 months can I get 80%? Okay, so in boards you have a very limited syllabus. So in that, maybe if you work hard enough, so getting a certain percentage in a certain amount of time in boards is easy. It can be defined very well. But when you're talking about a competitive exam like JEE, and when you're talking about cracking JEE, so I don't know what your definition of cracking is. So that may be very different. So if say you want to aim for a top rank, only JEE Mains, and what kind of rank are you aiming for when you say that you want to crack JEE? What kind of rank are you aiming for? What do you think? So please be more specific so that I can answer you more appropriately. Okay. Again, on top of all these benefits which I've already discussed, now Unacademy is also providing you the opportunity to study from India's best educators from the comfort and safety of your home. So now this is a great feature which is available for you in your offline setups. Also, you couldn't have done that. Now you have the chance to study from any of the top educators all across India. Okay. So, okay, 95 percentile. Okay, let's see. 95 percentile, that would mean somewhere around 50,000 rank. Okay. Yes, I would say that that is possible. That is possible, but you'll have to really work hard. You'll have to work really hard, and I hope you have some of your fundamentals already in place. Okay, then yes, it is possible. Okay. Next, so how do you get this subscription, and how can you enroll or be a part of this great academic movement that Unacademy has started? So first step is installing the Unacademy app. Now, the moment you install the Unacademy app, you already have access to a lot of free courses and free special classes. So free courses and special classes you can already enroll with just after installing this app. You don't even have to get a subscription for that. So you can install the app, use the code RDLive to unlock these features. Okay. So that would be easy. Okay. So yes, sir, working hard. So if you're working hard, then that should be possible. Okay. That should be possible. And best of luck from my side. Okay. Next, once you have installed the app, once you have seen all the free features, free courses, and free special classes available, if you like the content that you see, so you'll get a glimpse of the experience that you are going to have when you get a plus subscription. All right. So if you like that glimpse, then if you want to convert and buy the subscription, then this is what you can do. You can go to the plus section of the app, select your goal as IITJ, and click on that get subscription button. Now, Unacademy also provides you the iconic subscription now along with the plus subscription. So iconic subscription, what is it? This is something, this is a new feature that Unacademy has started to offer. Now this will take your IITJ preparation to the next level with the help of personal coaches that are assigned to you. Okay, so this gives you a more personalized JEE preparation. All right, so you are allotted some personal mentors, and you also attend time to time JEE workshops. Then you receive timely expert guidelines. You have a study planner, and you have test analysis sessions. So with all those, and with closely being mentored by a team of experts, it will take your JEE preparation to the next level. Absolutely. Next, when you have clicked on Get Subscription button, you would be redirected to the payment page, where you will realize that you can go for any kind of subscription, and there you can use this code RD Live to get a 10% off on all your subscription fees. Okay, and when you click on Proceed to Pay, you'll also realize that you have a lot of no cost EMI options available for making the payment. So that will make sure that you don't feel the burden of these payments. All right, another great opportunity to get yourself the Unacademy subscription is by competing in the Unacademy Combat. So this is the most competitive gamified IITJ battle. So you can compete live in this, and if you do well, you can win yourself prizes and rewards. So first of all, it's a great I think practice if you compete here. Then secondly, it is a great opportunity for you to realize your potential, where you are in terms of your standing in the competition compared to your peers. And third, if you do well, then you stand a great chance to win a lot of cool rewards and prizes. These prizes include a lot of cash prizes, plus a lot of Unacademy subscriptions are being given away for free. So why don't you compete in this? The next event is going to happen on the 20th of December. You can enroll now using the code RD Live. And if you've been following my lectures, trust me, you will do well there. And with some luck, I think you can even win yourself the 1 year subscription completely for free. All right, along with other prizes, of course. Now, Unacademy is also bringing a class 10th boot camp for all the students who are planning to start preparing their studies for a JEE 2023. So all these students can enroll in this and get an experience of how your JEE preparation is going to be. So this boot camp is going to be available from 13th of December and will go on till the 19th of December. So any class 10 students planning to get started with their JEE preparations should enroll and check it out for themselves. Next, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. So this will make sure that you're getting all the notifications of all the lectures and the amazing sessions that are happening here on the JEE English channel of YouTube. Okay, right. So next, why don't we get started with today's session? So today we'll be talking about problems on rotational motion. Okay, and let's see. Again, I have to start with, I have selected a few problems from the Pathfinder book, but to my disappointment, a lot of problems. There weren't a lot of problems, and most of the problems for JEE were not very relevant and not really good. So I have a much better collection myself for JEE advanced problems on rotational mechanics. So today we'll start with the Pathfinder problems, and in the next class I'll take up some of my own problems, which should give you a great practice for both your Olympiads and your advanced. Okay, get started. So this is an interesting situation, by the way. So you've been asked two uniform triangular plates A, B, C, and ABD of the same thickness, height, and made up of the same material are shown in the figure. Now, if the moment of inertia of these plates about an axis PQ, so PQ is this axis passing through the base, okay, are IC and ID, which of the following statements is true? IC greater than ID, IC less than ID. Okay, yes, Saeed Umar. So, yes, I am a mechanical engineer. All right. Now, IC equals ID or D, more information is needed. Which one of the following options do you think is correct? Let's see. Why don't you guys give it a try? So this is an interesting situation, okay? So you don't know the actual dimensions of the two plates. All you know is that the base is common and the height is same. Okay, let's see what you can determine from that. Do you think that's enough information, by the way? I think that's enough information to judge the answer. Okay. So try this, and let's see if you can figure this out. This will also reveal you another very interesting fact, by the way. Okay, so let's see how many of you can figure this out. Okay, so I'm waiting for you guys to try. So who all are trying? Can you please let me know quickly in the chat? So those of you who are trying can quickly let me know in the chat that you're trying, so that I have some idea as to who all to wait for. Okay, let's see. Okay, those of you who are trying can just write trying in the chat. Okay, so that I have some idea as to who all I'm waiting for. So trust me, today we'll be discussing some very interesting situations and problems with respect to rotation. This should give you your brain a good jolt. Should be a good practice session. Some really challenging problems coming your way. So starting with this one, let's see. Okay, so S Pandey is trying. All right, how about the others? So I want all you guys to think about these problems, and all of you should definitely try. Okay, it doesn't really matter whether you're able to solve this or not. These are some really good challenging problems. So it is expected that most of you won't be able to solve. So that's all right. The idea of this discussion is me trying to tell you how to approach these problems. Okay, so Surat says C. All right. Let's see. How about others? How about others? Can someone else figure this out? Okay, S. Pandey also says C. Oh, well, that is very good, guys. So turns out C is the correct answer, which brings me to another interesting fact about a lot of triangles. So I will show you one thing that imagine if you had a triangle or any number of triangles for that matter. You make any number of triangles with a common base, okay, and you make this triangle one. You can make another random triangle, okay, or you can make any such triangle. The interesting point is that all these triangles will have exactly the same moment of inertia about the base as long as the base and the height are same. So let's try and prove that. Let's try and prove that. So to prove that, I'll just consider one triangle. Okay, so let's just consider one triangle and let's see what we find about that. Okay, so imagine that you have this triangle. Okay, so I'm taking up some random triangle like this. So no, I don't want to take it as triangle which appears to be a right angle. Okay, so I've taken up a random triangle, right? So we can divide this triangle into a lot of rods, correct, like this. So let's consider I'm talking about this one rod, which is at a height of y above the base and is having a thickness of dy, correct. Now let's also imagine that this has some length L. Okay, so this small rod has some length L. So you realize if I can find the moment of inertia of this small rod about an axis, which is this, then using the parallel axis theorem, I can find the moment of inertia of this small portion about the axis PQ. Okay, this was the axis PQ, right? All right, so let's go for it. So for any rod, the moment of inertia about its own axis is zero, right? So using parallel axis theorem, what I can say is using parallel axis theorem, what we get is that DIPQ. So the moment of inertia of this small portion about the axis PQ, how much is that going to be? That is going to be dm y square, correct? Because the moment of inertia about its own axis is going to be zero, which is the axis passing through the center of mass. So for a parallel axis, it is 0 plus md square, where d is the perpendicular distance. The perpendicular distance between the two axes is y. Okay. So do you guys agree? So if you have any doubt about this, let me know. That this is what I will get my d of IPQ as. Okay, the moment of inertia due to this small portion that I have considered here. Okay, so if everybody is fine with this, then let's move ahead. And I can now also say that what about dm? So can I write dm as L times dy, which is the area, into sigma, which is the density, mass density of this rod, right? Again, I hope no objections there. Okay, so what I'm getting is that d of IPQ is nothing but L rho y square, correct? Now, can I relate L and y? I absolutely can. How? So let's see. So let's give these sides some names. So let's call this A. Was it? Yeah, A was down. Let's be consistent. So this was A, this was B, and this was D, right? So if you see triangles and let's call this E and let's call this F. So you will realize that triangle DFE and triangle DAB will be similar. Read, if this is theta, like this is also theta, and these angles will again be equal because they are corresponding angles. Okay, so these two triangles would be similar. Also, one angle is common, so you can say. Okay, so I can say now that since triangle ABD is similar to, so similar to was this, I think, if I remember correctly, is similar to triangle DEF. So from similarity, what I can say, if the height is h, if this entire height is h, so can I say from similarity that if this base is b, so can I say h over b should be equal to the height of this triangle, which would be h minus y over the base, which is L. So h minus y over L. So from here, what I can get is L equals b times 1 minus y over h. Correct? Hello, Rohit Yadav. How are you? No man, sir, take some tough problems. Okay, so you don't find this tough? No man. Strange. I thought I was taking up tough problems. Okay. All right. So now if I substitute that, let's see what I'm getting. I am getting d of IPQ becomes equal to sigma b 1 minus y over h times y square dy. Correct? Again, you can let me know if there is any step that you're not following. You can absolutely let me know if there is any step that you're not following. Okay. Now all I need to do is to find the net moment of inertia. I'll integrate this and I know the limits of y. Y will range from 0 to h. Correct? Let's see. I think I'll have to add one page here. Let's see what we are getting. So I was getting d of IPQ was, what was it? Rho times B, so rho times, I can write this as y square minus y cube over h y, and integral of this from 0 to h. Correct? Again, you can let me know at any time if there is any step that you're not following. Okay. So yeah, I think I've written that correctly. Y square minus y cube by h. Yes, absolutely. All right. So now you will realize when you integrate this, what is IPQ? I about PQ would be sigma B, and then you would have had y cube by 3 minus y to the power 4 by 4h, and ranging from 0 to h. So when you substitute these values, what you're getting is sigma B times, you have h cube by 3 minus h cube by 4. So you have 1 by 12 rho B h cube. So what you realize is that this depends only on the base and the height of the triangle. Okay, I hope you can see that. Depends only on the base and height h of the triangle. Right? Will you take a session on Erudov problems of rotational motion? Absolutely. In fact, I did say that surprisingly the problems on rotation from this book Pathfinder were a little disappointing. I wasn't too happy to see them. I did not find them good enough. I think Erudov has got better problems on rotational motion. So in the next session that I conduct for this only, I would take up problems from Erudov and from other books also. Trust me, I've got a good collection of books myself. So I will bring you some really nice, very, very amazing problems. Okay. So don't worry about it, Noman. Okay. So as I said, what you realize is that the moment of inertia about the base of any triangle, moment of inertia about the base of any triangle depends only on two things: the length of the base and the height of the triangle. Now you realize for this, in this situation, for both these triangles, the base and the height are common, right? Both of them have the same base B, and both of them have the same height h. So for these two, the correct answer would be C. The moment of inertia would in fact be equal. In fact, for all such triangles. So that is a very interesting fact. That is a very interesting fact that the moment of inertia of any triangular mass distribution, uh, as long as the base is same and the height is same for all these triangles, the moment of inertia would have been same. You could have taken any of these triangles, it would have just been the same. Okay. Okay. So I hope you guys followed this. So please let me know if somebody did not follow any part of the solution, and or if somebody has some doubt remaining. Okay. If you're not entirely convinced, let me know. I'll go over that part one more time. So till the time you guys take a look at the solution, I'll help myself with some water. Okay. So Noman, again, as I said, trust me, rotation was my favorite topic even as a student. So I have a huge collection of amazing problems on rotation. So I will be covering those also, because this discussion I don't want to just simply limit it to Pathfinder problems only, because honestly I thought there were not good enough problems in Pathfinder. Okay. All right, AP says C. Okay. So if everybody followed this solution, then should we move ahead to the next challenging problem? Okay. So here is your next problem. This is another very interesting problem. This says a uniform steel rod leans against a frictionless wall. So pay attention to the language. Pay close attention to the language. Uniform steel rod leans against a frictionless wall in static equilibrium. Okay, so what is static equilibrium? So it is at rest and it is at equilibrium. Okay. Now frictional force, however, between the lower end and the floor is less than the limiting value of the friction by some finite amount. So it is not even close to the limiting friction. Okay, that has been told to you. Now you've been told that the rod is supplied some amount of heat so that it expands. Okay, so that is what you have been told. You heat the rod and it expands. Assume that the coefficient of friction does not change on heating. What can you conclude regarding the contact forces on the from the wall and from the floor? What can be concluded about these two contact forces? So option A says from the wall it decreases and from the floor it increases. Option B says from the wall it increases and from the floor it decreases. Option C says from the wall as well as from the floor it increases, and option D says well, from the wall as well as from the floor it decreases. So what do you think is the right answer for this? Give it a try. Give it a try. Think about it. Let's see if you can figure this one out. This is a slightly tricky problem. Okay, so be careful about answering this one. Okay. So try this and try and give me your answers. Let's see. Let's see. What do you guys think should be the answer? And then of course I will discuss the solution. But I want all you guys to try first, think about an answer, try and explain your answer, and then we'll see if what you figured out is correct or not. All right. So how many of you are thinking about this? What happened to Suraj? So I saw Suraj after a long time in my class. Okay. So I think Suraj was having school examinations or something. He said that in the last time. Okay, so if you're trying, let me know and let me know what you think the answer should be. Let's see. Okay, Suraj is trying. I knew Suraj would be trying. So Suraj is a very hardworking fellow. Whenever he comes to my class, he always tries all the problems, which is very nice, which is the way to attend classes. Always attend these classes live and try to analyze the situation here only. So that if there is something that you don't think makes sense, you can ask right away. Okay, when you're watching the recorded session, then either you will not think about the problem at that time, you will just listen to my solution, which trust me doesn't help you much. So first you need to think about the solution and then you need to discuss it with me. Okay, so all right, all right. All these guys are trying. See, let's see. So you'll have to bear with me for a little bit because I am having a sore throat. Okay, people. So not only you have to think about the question and tell me the answer, but also let's discuss have a discussion over the solution. I mean, why do you think the answer should be something? So not only try and give me an answer, but also try and explain why. Okay. Okay. All right. Interesting. So S. Pandey says it's D. Okay. How about Suraj? What do you think? Okay. Let's see what does Suraj think about this? Since there were two guys who were trying. Okay, so let's just wait for the second person also. And let's see, let's see. Suraj says it's A. Okay, so Suraj says from the wall it decreases and from the floor it increases. All right, and two people think it's D. Let us see. So please realize first what we'll do is we will try to analyze the situation. Okay, first let's try and analyze the situation. Now, whenever the rod is resting like this, if I make the FBD, let's see how the FBD looks, right? I will have one normal reaction acting from here. Let's call that N1. I'll have one normal reaction acting from here. Let's call that N2. And then I will have a friction which will be needed to balance this N2, right? Call this F1. And the wall is smooth, so you cannot have any friction on the wall. Then you'll have Mg, right? And of course, you have Mg. Okay. So first of all, as long as the rod is resting like this, as long as the rod is in equilibrium, so I can say that the net force acting on the rod in all the directions must be zero. So I can say for equilibrium of the rod, can I say that N2 must be equal to F1 and N1 must be equal to Mg. Okay, so I am writing that the net force in all the directions must be zero, correct? Okay. Next, also I will realize since the body is in static equilibrium, so it will be in rotational equilibrium as well. So for rotational equilibrium, torque about any point must be zero. So taking torques about, let's say this point, let's call this, we have a name of this point. No, we don't. So let's call this A and let's call this B. For rotational equilibrium, taking torques about A, let's see what that gives me. Taking torques about A, I will get that mg times L by 2 cos theta, right? This would be L by 2 cos theta. And this would be L sine theta. So it should be equal to N2 times L sine theta. Right? So L gets cancelled. And what I have is N2 equals mg by 2 tan theta. The first thing that I will realize is that no matter what happens, N1 remains the same. If the rod has to remain in equilibrium, N1 is always equal to mg. Similarly, N2 is equal to F1. So what is the net contact force from the ground? So net contact force from the ground is F from ground is root of N1 square plus F1 square, and F from wall is simply N2. So first of all, what you need to realize is since N1 does not change, even if the rod expands or does whatever it does, okay, because this is a smooth wall. Okay, so I hope think about this. This is a smooth wall. So this cannot external forces. If you talk about the external forces, this cannot provide a force in the y direction. So the only external force in the y direction is mg, right? If the only external force is mg, so you realize N1 always has to be equal to mg, right? Similarly, N2 is always equal to F1. So if N2 decreases, F1 decreases. If N2 increases, then F1 increases. So can I say that this cannot be the answer? Suraj, do you agree that this cannot happen? This cannot happen. It will be either this or this. Either both will increase or both will decrease for the rod to always remain in equilibrium. Okay. I hope you guys agree to that. So Suraj, can you figure out this, what I just said? Now you will also realize that, fine, assuming that the rod doesn't slip at this end, how about the other end? If it expands, you will realize if it expands, then how will the rod be oriented? So the rod may turn by some angle like this, okay, when it expands, because there is nobody there to stop it from moving up. Okay. Now, do you realize during the expansion, even if the rod expands, the mg does not change. So you realize N1 remains the same. About N2, N2 is mg over 2 tan theta. So if theta increases, mg is unchanged, so N2 decreases. Right? When this expands, your theta increases. If your theta increases, so I can say since theta increases, your N2 actually decreases. And if N2 decreases, F1 also decreases. F1 decreases as well. So if F1 decreases, N2 decreases, then the correct answer would be in fact D. Both the forces from the wall and the floor both will decrease. Okay. Now, do you get the answer? The answer would be D. D is the correct answer. So congratulations, S. Pandey and Amod Kumar. You guys absolutely nailed this. All right. Okay, so this is how you would have done this. Again, since the friction was, we will say, if we heat it slightly, then friction was less than the limiting value by a decent finite amount. So slightly heating it would just make it expand, move it upwards. Okay, and that is why option D would be the correct answer. Okay. All right. Now let's move on to the next question. So this is a theoretical question, but I found this really nice, and I thought a lot of people don't think about this. So that is why I wanted to discuss this. So you've been told a rigid body is observed to be in equilibrium in a particular non-rotating, non-inertial frame. So please be careful about the language. The rigid body is observed to be in equilibrium from a particular non-rotating, non-inertial frame. Okay, so the reference frame from where you see the body to be in equilibrium is a non-rotating and a non-inertial frame. Now, what can you conclude if the body is observed from an inertial frame? So the options are A, the body is in rotational equilibrium, but not in translational equilibrium. Option B says the net torque of all the forces on the body about its center of mass is a null vector. Option C says the net torque of all the forces acting on the body about any point that is collinear with the line of acceleration of the center of mass is a null vector. Okay. And you have the net torque of all the forces on the body about all points of the line that is parallel to the line of acceleration of the center of mass is a null vector. So go through the options and think about this a bit. This is a theoretical question, but you should know about this. Okay. Now, please also note when you say that the body is in equilibrium, it means whenever I say the body is in equilibrium, it means it is in both rotational and translatory equilibrium. Please remember this. Whenever you say a body is in equilibrium, then you mean to say that body has both the equilibriums. Okay, which means it has both translatory equilibrium as well as rotatory equilibrium. Okay, so now think about this problem and try to give me an answer. By the way, more than one options may be correct in this case. Okay. So be a little careful. Be a little careful about this. All right. Let's see if you can figure out which are the correct options. Okay, so AP says A, B, and C. Mm-hmm. Okay, okay. How about others? How about others? Despane says A and B. Okay, interesting. So anybody else who would want to give it a shot? How about Suraj? Suraj, what do you think about this? Again, you should never take these conceptual questions lightly because JEE Advanced likes asking a lot of conceptual problems, and conceptual, theoretical questions give you a greater clarity of your concepts. Okay, so try and answer this. Try and think about this. Let's see. So Suraj also says A and B. Okay, okay, okay. Okay, so turns out AP is correct. A, B, and C all are correct. Okay, how is that? So imagine this is your random rigid body. Okay, now you are observing it from a non-rotating and non-inertial reference frame. Okay, so you observe it from a non-inertial reference frame. So imagine you are an observer. You are an observer who is accelerating with some acceleration a vector. So you realize from your reference frame, along with all the real forces, you will also have a pseudo force acting on the CM. Now, please remember that pseudo force always acts on the CM. The logic of that I have explained in my class. I don't know if I have. Okay, so maybe if I haven't, I don't know. I will explain it one more time. So how do you know that the net pseudo force acts on the CM? So first I'll tell you that the net pseudo force acts always here, and its value is m times minus ma of observer, where a of observer is the acceleration of the observer. So the net force always acts at the CM. Okay, why is that? Why is that? So when you're representing the pseudo force, you are basically representing the net force and the effective position of that force, right? So you will realize if I consider this to be made up of a lot of point masses, then actually all these point masses would feel a pseudo force, correct? All these guys, all these point masses that are making up this rigid body would have felt a pseudo force individually. Individually, every mass would have felt a small ith particle would have felt a pseudo force like this, right? Now, the average position of that would have come to be at the center of mass. So why? Think about this. Think about this. When you were finding the center of gravity, when you're finding the center of gravity, what did you do? The center of gravity was the average position at which the entire weight of the body can be considered to be acting, right? Imagine here every mass, individual mass would have felt a force of gravity, right? And how much would that be? So mi times g. So m1g, m2g, and so on, so on. So if g is uniform, if the g does not change, then you realize that the average position comes out to be at the center of mass only. It is very similar to that. The pseudo force that every small mass is feeling is directly proportional to m and has a constant multiplied with it, just like this, right? And all of them have the same direction. So the average value of the force can be considered to be acting on the CM, just like the weight would have been considered to be acting here, which would have been m times g. So I think that should make sense to you. So does that make sense? Let me know. So I hope you're convinced with that. With the net, all the pseudo force, the effective position of the pseudo force would be acting on the CM, and it would be having a magnitude of, or the force, pseudo force would be minus m times a naught vector, and it will act at the CM. Let me know if this made sense. Okay. Now, what has been given to me in the question? So I have been told that this body is observed to be in equilibrium. So if this body is observed to be in equilibrium, so acceleration of CM, can I say acceleration of CM with respect to the observer is 0? So since in this reference frame, the body is in equilibrium, therefore acceleration of CM with respect to observer must be 0, right? What does that tell me? That tells me that acceleration of CM with respect to ground is acceleration of observer. All right. Also tells me that summation of all the torques about the CM would be 0. Now you realize this pseudo force does not produce any torque about the CM. The pseudo force is not producing any torque about the CM. So whatever be the forces acting on this, so even if you had many forces acting on this, so summation of all the torque due to all the forces must be 0. So since the pseudo force does not produce any torque, all the other forces just remain like that. So in ground frame, what you would have seen is, see, in ground frame, you would have seen the same body, except for this force, all other forces would have remained, right? Except for this force, all other forces would have just remained like that. So if in this reference frame, the net torque of all these forces about the CM is 0, then you realize in the ground frame also, this will be true. Okay. So since the pseudo force does not produce any torque about the CM, just like mg. Remember, mg never produces any torque about the CM. So similarly, the pseudo force does not produce any torque about the CM. So therefore, I can say summation of all the torques about CM in ground frame would also be 0, or any inertial frame for that matter. Please don't, sir, we don't see your cursor. Please make it visible. Okay, so that's because there is no cursor. There is no cursor. By using red dot. Okay, so is that fine? Is that okay? If you want to see, I can show you like this. Okay. So anyhow, as I was saying, so I can definitely say that the net torque about the CM would be 0. Now, can I also say, if in this reference frame, since the object is in equilibrium, if the object is in equilibrium, that means that in this reference frame, the torque about any point would be 0. So that is another interesting thing. Not only the torques about the CM would be 0, but the torques about any point in this reference frame would be 0. Agreed? I hope you can see that in this reference frame, the torque about any point would be 0, because whenever a body is in rotational equilibrium, then the torque about all the points is always 0. Now you will realize, if you consider this special line, then for any point along this entire line, the pseudo force does not produce any torque. So about all the points on this straight line, even in ground frame, the net torque must be 0. Okay, so that's the logic of option number C. What does option A say? Option A says that the body is in rotational equilibrium but not in translatory equilibrium, which is correct because the body has an acceleration with respect to ground. In the inertial frame, the center of mass has an acceleration, so obviously there is no translatory equilibrium, but because of this, there is rotatory equilibrium. So this is correct. Second option says that the net torque of all the forces on the body about its center of mass is a nil vector, which is also correct. Third is that I can realize in this reference frame, non-inertial reference frame, the net torque about any of such points, of all the points, about all the points on this entire line would be 0. And since the pseudo force does not produce any torque about any of these points, so you will realize, see, along this straight line, even in ground frame, along this straight line, all the other forces must be producing 0 torque because pseudo torque was never producing any torque. So can I say at any point P on this line, can I say summation of tau about P must be equal to 0? So this tau would be due to all the other forces, right? So it will be holding true in the ground frame also. So that is why option C is also correct. Okay, the net torque of all the forces acting on a body about any point that is collinear with the line of acceleration of the center of mass is a null vector. Now, about option number D. Option D says that the net torque due to all the forces on the body about all points on a line that is parallel to the line of acceleration of the center of mass is a null vector. Let's see if that is the case. So if I take another line, if I consider another line here, let's say, now you realize if I take torques about this, so in this reference frame, in the non-inertial reference frame, the net torque must be 0. So I can say all the torque due to all the external forces. So summation of torque due to external forces about P plus pseudo torque of pseudo force about P, that must be 0, which implies that this is non-zero. The net torque due to all external forces about this P dash, let's call this P dash. About P dash, I can say that the net sum of torques due to external forces is non-zero, due to which this option is correct or is wrong. Okay, it will be non-zero because this is non-zero. Okay, since this is non-zero, so that term will also be non-zero automatically. Okay, this is non-zero, this will also be non-zero. Okay, I hope everybody followed this. So if you have any doubt about the logics that I've just told you, I've just explained, so let me know if you are fine with that. Sir, at the point on that line from where the observer is at perpendicular distance, there will be circular motion or not? Okay, so first of all, you are not talking about circular motion, you are talking about rotational motion. There is a difference between circular motion and rotational motion. This is rotational motion. This is circular motion. Okay, so there can be circular motion without any rotational motion. Do you understand that, Suraj? There's a difference between rotation and circular motion. Rotation is when the body is changing its own orientation. When the body does not change its orientation, then you can have circular motion like this. That is fine. Do you understand what I'm saying? Did you follow what I said? They are two different things. Hi Aditya, how are you? Okay. So we are talking about rotational motion, not circular motion. Of course, that's another thing though. In fact, for that observer, non-inertial observer, the circular motion will also be 0, by the way, because he is seeing the body at rest. Okay, he is seeing the body in equilibrium. Okay, it may be moving, it may be moving, it may have a velocity, that is fine. So it may have a circular motion, that's fine. All right, now let's move on to another very challenging problem. So this is a very interesting problem. In fact, I think you will really enjoy this. This is a very tough problem. This is a typical Olympiad level problem. So let's see what this question says. So this one is saying that a uniform square plate is placed on a horizontal floor. Okay, it's placed on a horizontal floor. When it is given an angular velocity of omega about a vertical axis through one of its corners, as shown in figure 1. So here is the plate. You have this axis and you're rotating this about this axis. Okay, and when you left it, it takes time t1 to come to a complete stop. हिंदी बोल. ओके, सो सहदेव मिस्त्री, फर्स्ट ऑफ ऑल अगर आपको हिंदी आती है तो थोड़ा सा इज्जत भी आती होगी बड़ों से बात करने की, है ना? तो हिंदी बोलिए, बोल सकते हैं आप. सेकेंड ऑफ ऑल, इफ यू लुक एट द चैनल, name of the channel is JEE English. ठीक है? So it's not like I am talking in English because I can't speak in Hindi. ठीक है, बहुत अच्छी हिंदी आती है मुझे. Okay, don't worry about that. But ये channel JEE English है. The mode of teaching in this channel is supposed to be primarily English. If there is something which you can't follow, then you can request and I will explain that in Hindi as well. Okay? ठीक है सहदेव मिस्त्री जी, अगर कोई चीज़ आपको इंग्लिश में जो एक्सप्लेनेशन देता हूँ अगर नहीं समझ में आती तो आप मुझसे पूछ सकते हैं. आई विल एक्सप्लेन दैट इन हिंदी. उसे हिंदी में भी समझा दूंगा. बट जेई इंग्लिश नाम है चैनल का, सो यहाँ पे इंग्लिश में ही पढ़ाना है मुझे. ओके, anyhow, so getting back to the question, let's see what the question says. The question says again, so it takes time t1 to come to a complete rest. So think about this. Why would that be happening when this plate is rotating and you kept it on a horizontal surface? Why would it come to rest? Any ideas? So first try and understand the question, okay? Try and understand the question first. Okay, so maybe you would like to answer in a bit. So let's move on to the next part. Now, the same square plate is given the same angular velocity to rotate about another vertical axis passing through its center as shown in figure 2. So this is figure 2. Now it is being rotated like this. So how long will it take to come to a complete rest now? Okay, so that is what you have to figure out. Think about this. This is a very tricky problem. I think this is one of the best problems that I've seen in a while. One of the better problems rather, at least. If not one of the best. Okay, so amazing problem. So you'll really have to think about this one. And figuring out the answer is very tricky. So think about this. Give it a thought. Get some thought. सोच के देखो. सहदेव मिस्त्री जी, if that is fine. ठीक है, आपके लिए थोड़ी हिंदी भी बोल देते हैं. Question क्या कह रहा है? Let me repeat that in Hindi. Just in case there are people who are not comfortable with English. See, the entire idea behind this channel is that language should not be a barrier in students' learning, right? If somebody is uncomfortable in English, that is absolutely fine. You can let me know and I will explain things in Hindi as well. ठीक है, ये जेई इंग्लिश चैनल इसलिए चालू किया गया था क्योंकि बहुत सारा जो यूट्यूब पे कंटेंट है वो हिंदी में अवेलेबल है एंड बहुत स्टूडेंट्स हिंदी में कंफर्टेबल नहीं है, तो उनके लिए है. बट अगर आप में से कोई है जो इंग्लिश में कंफर्टेबल नहीं है, सो यू कैन टेल मी, आप मुझे बता सकते हो एंड आई विल रिपीट एनीथिंग दैट आई हैव टू से. जो भी मैं बोल रहा हूँ वो मैं हिंदी में रिपीट कर दूंगा भाई, ताकि तुम सबको भी समझ में आ जाए, है ना? इसमें कोई ऐसा नाराजगी वाली बात नहीं है सहदेव मिस्त्री जी. तो क्वेश्चन क्या कह रहा है? पहले आपने एक स्क्वायर प्लेट लिया, इस एक्सिस के अबाउट किसी ओमेगा से रोटेट किया. ठीक है, ये स्क्वायर प्लेट एक हॉरिजॉन्टल फ्लोर पे रखा है एंड देखा गया कि ये कुछ टाइम t1 में रुक जा रहा है, ठीक है। नाउ उसके बाद सेम प्लेट को इस एक्सिस के अबाउट सेम ओमेगा से रोटेट किया गया, और अब अगर t2 टाइम में रुकेगा तो t2 टाइम कितना होगा? Can there be angular frictional force? Okay, so what is angular frictional force? भैया angular frictional force क्या होता है, पहले ये समझो. What is angular frictional force? है? See, whenever anything is slipping, there will be friction. And what is the direction of friction? कैसा फ्रिक्शन होगा? पहली बात, कैसा फ्रिक्शन होगा? काइनेटिक फ्रिक्शन. और what is the direction of kinetic friction? काइनेटिक फ्रिक्शन का क्या डायरेक्शन होता है? हमेशा ऑपोजिट टू द वेलोसिटी. Okay. So yes, it is the torque of frictional forces, in fact, that will slow this down. Right? आप प्रैक्टिकली भी करके देख सकते हो, है ना? On any surface on a table, if you're rotating something, after rotating for a bit, it will come to stop. Why? It is the torque that is being provided by friction. ठीक है? फ्रिक्शन कुछ ऑपोजिंग टॉर्क प्रोवाइड करेगा, उसकी वजह से रुक जाएगी चीज. Okay. So let's try and think about this. Let's try and think about this. This was your plate. Imagine that it is rotating about an axis which is going like this, right? ये आपका axis है, it is rotating like this. Okay, the rotation direction is the opposite, right? Hmm. So it is rotating like this. So if you realize the if you consider a portion like this, okay, consider a portion like this. So that's my hint to you. Consider a portion like this. So all this portion, this entire portion, all the mass here is actually moving with these velocities, right? So this is moving here, this is moving here, this is moving here. So because of these velocities, there will be kinetic friction, right? है ना? और kinetic friction कैसे लगेगा भाई इन parts पे? Kinetic friction हमेशा ही velocity के opposite लगता है. So this will be the direction of kinetic friction acting at these points. Right? Now this kind of kinetic friction would produce a torque, an opposing torque. Okay, ये एक opposing torque produce करेगा about our axis of rotation, which is essentially what is slowing your plate down, right? कुछ कुछ समझ में आया? सूरज, did you follow this? कुछ चमका? समझ में आया क्या हो रहा है? Okay, so whoever is watching, do you guys follow? Let me know. भाई बताते रहो कि समझ में आ रहा है कि नहीं. मैंने जो बोला अभी कुछ कुछ समझ में आया, कुछ कुछ भी समझ में आया आपके? Enlightened. Sure. Great. Now think about this. Now can you figure out what is the time it will take to come to a complete stop? Now that is going to be super tricky, by the way. That is going to be super tricky. That is not an easy thing to figure out. Okay. In fact, when I was picking up the questions, no, I wanted to take the questions for which the solutions, some common standard situations, and also the questions for which the solutions should not be available online. Okay, so this was one question which people had like posted at different places, but nowhere is the solution given. Nowhere. You won't find the solution of this anywhere online. So that is why I wanted to take this up. This has a tricky solution, which is not easy to figure out. Trust me. I mean, I tried this. You can Google this and you can see if you can find the solution of this anywhere online. Okay. Okay, great. Sure, sure, sure. Trust me, I'm in no hurry about this question. Okay, you can take as much time as you want. This is a wonderful, wonderful problem. So I want you to take your time with this. Okay. Think about this. There are many ways to solve this. In both cases, torque due to friction will be same. Okay. Think about this. Think about this. I don't know. I have no idea. Let's see. I don't think so, by the way. I don't think so. No, the torque would not be the same, by the way. Okay. Of course, the torque of friction would not be the same. But you can still think about this. Okay, so you know what? You know what? In fact, this is such an amazing problem. I would like you guys to take more time with this one. So we will discuss this in the next class. So let me give you this as the homework. Okay. So I will discuss the solution of this in the next class. In fact, okay. And there is a slight bit of manipulation, mathematical manipulation that you'll have to do to figure this solution out. Okay. So I want you to spend some more time how to do that. Okay. The talk in both the cases would not be the same. First of all, let me tell you. Think about this. Think about this. So okay. So I'll give you a hint, a small hint. Maybe if you had to calculate the torque. So if there is mass dm over here, if there is mass dm over here, so what would be the force of friction for this entire strip? I hope you realize that force of friction, small df, would be dm mu g, correct? What will be the torque that it will be producing? D tau would be equal to dm mu g times r, where r is the radius of this thing that I've taken, right? So there is one hint. Now I would like to think. I would like you guys to think a little bit more about this problem. and maybe we will discuss this in the next class. Okay, you can leave your answers in the comment section, by the way. Leave answers in the comment section, and Espana says B. So no, B is not the correct answer. Leave answers in the comment section. Take some more time to think about this problem. This is, as I said, this is one of the best problems that I have come across in a while. One of the better problems that I've come across in a while, at least, as I keep saying. Okay, so you can think a bit more about this and leave your answers in the comment section. Maybe I'll discuss the solution of this in the next class. I don't feel like giving out the solution so easily. Okay, just put in some more effort. Till then, let's try another problem. Okay. So right now, let's try and focus on another problem. We will come back to that problem in the next class. Okay, so in this problem, you've been told two uniform disks A and B of equal masses and different radii, RA and RB, are mounted on a fixed horizontal axle passing through their centers. Okay. Now you've been told that a light on each of these disks, a light long cord is wound and the disks are held motionless. Okay. If the free ends of both the cords are pulled with equal forces F for equal amount of time, the lengths of the cord unwound from the disk uh, are LA and LB. What will be the relation between LA and LB? So think about this one. Okay. This is a relatively easier one. This you should be able to solve, right? So think about this. Think about this. This is a relatively easier problem. So let's give you a slightly easier problem for right now, and you can take your time with the previous problem, because that is a new kind of a problem. You probably don't. So such problems are there in fact Erudov, you have such problems where rotating disks are slowing down because of frictional torques, right? But usually, except for that one, a couple of problems in Erudov, I don't think you find these kind of problems very easily. And there also it's about disks. So in disks it's slightly easier. Okay, this will take some more time and some more effort. So think about this. So coming back to the present problem, what do you think is the answer to the present problem? So what will be the relation between the lengths unwound in some time t? Okay, this should be simple. Come on, give me some answers for this. Give answers for this. Come on, people. This should be easy to figure out. This is way easier. No, this is way easy compared to the previous one. Previous one is going to be tough, and that is why I want you to take more time with that one. But this should be easy. You should be able to figure this out already. By the way, okay. Let's see. So AP says C. Okay. All right. How about others? Is anyone else trying this? Anyone else trying this? So only APA has tried this. Anyone else trying? So should I wait for anybody else or should I go ahead and show you the solution? Okay, I guess no one else is trying. So let's go ahead and figure out the solution. So imagine you have this equation, right? You are applying a force F here, and let's say that, see, these two uniform discs, this have equal masses, right? Equal masses. So let's say M. Okay, answer for which one? For this one or the previous one? For this one, the answer is in fact C. C is the answer. Or do you want the answer to the previous one? Again, as I said, I have asked you to leave your answers in the comment section. That's why I'm not telling you the answer for this. Okay. Now let's talk about this. So if assume that the mass is M and assume that the radius is R, if you take torques about the center, what will you get? This one is C only. C is the correct answer. Okay. So taking torques about the center, taking torques about the center. What do we get? I have only one torque. Okay, that is due to F. So I can say F into R would be equal to, and this is a uniform disk, right? Uniform disk. So that should be equal to 1 by 2 mr square times alpha, correct? So what is it? So I am getting my alpha into R as 2f over m. Now you realize the acceleration of this point, if this guy has an acceleration A, then the acceleration of this point is in fact alpha R. So you realize the acceleration of the end point is independent of the radius. It depends only on the force and on the mass. Since the same force was applied on both the discs and both discs have the same mass, so the acceleration of the edge is always the same, because of which the answer would in fact be C. Okay, I hope you guys followed this. There was another way in which you could have seen this. Another way in which you could have seen this was that if you think about in time t, what is the angle turned? What is the angle turned in time t? So can I say that in theta would have been half alpha t square? That is the angle turned. If you find the angle turned in time t, then the length that has become unwound, L, would have been equal to r times theta. What you realize is, again, if you calculate the length from here also, then what you're getting is this should be r into 1 by 2 into alpha, which is 2f over mr times t square. So you will realize that the length unwound would be f by m t square in time t, independent of your radius. So as long as f and m are same, you would have had the same lengths that would have gotten unwound, correct? So C is the correct answer. So let me know if you followed this. In case you have any issue with this, in case there is any part of the solution that you did not follow, you can also let me know. Now, ये समझ में आ गया? This is easy only. This is a standard easy question. Again, when I say easy, I mean easy for anybody who has strong fundamentals and has practiced. Okay, might be difficult for somebody, so don't think, okay, sir is saying this is easy, I found this difficult. It's all right. It's all right. That just means you need more practice. If you solved a lot of standard questions, you will realize that this is a very standard method of solving this. So if you had enough practice, this should have been easy for you. Okay. So any doubts? So if there are no doubts, should we move on to the next one then? Okay. Moving ahead. This is another very interesting problem. This says a small disk is attached to one end of a light inextensible string that passes through a hole in a frictionless horizontal tabletop. So here you can see this is a disk. It has a thread passing through this, and this is a frictionless. So let's highlight that word. So light inextensible string, first of all. and we have a frictionless horizontal tabletop. Now, initially, the disk moves in a radius of r with a kinetic energy k naught. Now, the other end of the string is pulled slowly so that the disk finally moves in a circle of radius, which is given as r over neta. Okay, what is the work done in pulling by the pulling agency? What is the work done by the pulling agency? That is what you have to find out. Think about this. This is again not too difficult. Not too difficult. I think this would be called moderately difficult. It's not like those super hard problems like the earlier one. Okay, so give it a try and let's see how many of you can figure this out. So think about this. Think about this. This is a pretty standard kind of a problem. So what do you think will happen when you pull this? Think will happen when you pull this? So think about that, and then you should be able to answer this. Shivam Guider of COC. So is that Shivam Dixit? तो तुम यहाँ भी आ गए. So Shivam has been following me throughout the day. So he attended my first YouTube class, then he attended my class on YouTube, Unacademy Plus, and now he's here. ये कराया है पहले? नहीं नहीं, ये नहीं कराया है मैंने पहले. ये नहीं कराया है पहले. Hmm. So this is a standard problem though. मतलब बहुत ज़्यादा difficulty होनी नहीं चाहिए इसमें यार. Hmm. Okay, so AP says C. How about others? बाकी लोग का देखते हैं क्या कहते हैं बाकी लोग. So this will be the last problem that we'll be discussing today. I think we have run out of time, so I have planned this session only for 1.5 hours. So we are almost out of time. Tanya says D. Okay. Okay. So AP says C and Tanya says D. Interesting. How about others? Okay. So first of all, of course, work cannot be zero. So that immediately you can rule out. Okay, this option you can immediately rule out. It cannot be zero because when you are pulling, you are applying such a force. So such a force and this end is getting displaced. Definitely because you're shortening the radius. So the end is getting displaced. So the work has to be non-zero first of all. Now, since you have been asked to find the work done. Now, work done is usually change in kinetic energy. So I have a feeling because it is change in kinetic energy, I should have a term of -1 in the answer. Okay. So even without solving it one bit, use tension concept. सोचो कैसे? Even without solving it one bit, I immediately know that the answer should be either C or D. Okay, that is something that you can get from common sense only. So a lot of times you don't even have to solve to figure out which options to eliminate. Again, please remember this elimination is also very important. I will in fact take an entire session of how to eliminate options because that is sometimes really helpful, especially in competitive exams when you don't have too much time to solve your problems, right? So if you can eliminate two options at least easily, then you have a 50% chance of uh, getting an answer correct, right? Where you had absolutely no idea. All right. So let's see. What will happen is that initially, let's imagine that this guy was rotating in a radius of r. Okay. And let's say this had an omega. It was moving with a certain omega. right? So this was r, and it was moving with a certain omega. So what will be the k naught? Value of k naught would have been half mr square omega naught square. Give this the name omega naught, and since this was capital R, let's take to capital R. Work done delta K, exactly, Shivam. That is what we are going to use. So I find my initial kinetic energy first. Now, when you have pulled that string down, and let's say finally it is moving in a smaller circle. Now you will notice one thing, that during this entire motion of it being pulled, if it being pulled from here to here, is there any external torque at any instant on this particle about the center? That's what you have to figure out about this center. Let's call this O. So think about this. Think about this. About this point O. Even when you pull this string, and even when it moves towards a smaller circle, for the entire duration, you realize the tension is the force which is acting on this. So you never have any external torque about this center O. What does that tell me? That tells me that the angular momentum of the disk about O should be conserved. Okay, very, very standard thing to have figured it out. Okay, not really something completely out of the blue. So I can say, since there is never a net external torque on the disk about O, therefore the angular momentum of the disk. So you should have seen such questions which are solved using the conservation of angular momentum. Yes, L is conserved. So the angular momentum of the disk with respect to O is conserved. Hmm. So can I say I1 omega 1 would be equal to I2 omega 2? What is I1? I1 was mr square into omega naught. This should be equal to m times r by neta whole square times omega. Okay. Because the final moment of inertia about O would be, it is always mr square, right? So from here, what I get is this, and this gets cancelled, this and this gets cancelled. What I realize is omega is nothing but neta square times omega naught. Okay, I hope you guys followed that. Yes, the force would be centripetal in nature, not exactly centripetal. It would have a radial acceleration also, by the way. But so I now find the final omega. If I have the final omega, I can find the final kinetic energy. Final kinetic energy would be half. Okay, so stick to capital R only. So half m r over neta whole square into omega square, which would be omega naught neta square whole square. So what you are getting is half k r square omega naught square neta square. Correct. So this is neta square times k naught. Now all I need to do is apply the work energy theorem, and I can say work would be equal to delta Ke. So delta Ke is nothing but this. Okay, so neta square minus 1 K naught. So that would be the work required in pulling that string. Okay, I hope everybody followed this. I hope everybody followed this. All you have to do was apply an angular momentum conservation, find out the value of the new energy. Energy has increased. So why is the energy increasing? You must have done some positive work, right? The external agent is doing some positive work. It is applying a force like this, and you realize this point is also getting displaced in this direction. So force and displacement are both in the same direction. So external agent is doing some work in the in pulling this. So hello, shorts guy. So what are you trying to say? I'm not sure what you're trying to say. So option C is correct, in fact. Okay, I hope everybody followed the solution. This is it, and that is our time for today. Ah, that is sad. Hmm. Anyhow. So that concludes our time for today. I think time for today is up. I did have more questions to discuss, which again I can discuss in the next class. So again, this is your homework problem, and a very amazing problem, in fact. So think about this. Hmm. Yes, but shorts guy, right now is not the time to focus on movies. Just keep your focus right. Okay, shorts guy. So this is your homework problem. Try this. This is again an amazing problem. We will discuss the solution of this problem in the next class. Right. So that is my time for today. And before I leave you guys, let me remind you: if you haven't gotten your Unacademy subscriptions yet, what are you waiting for? What are you doing? You don't have any time to waste. So go ahead and get your Unacademy subscriptions as fast as possible. And this is how you do it. So go to the plus section of the app, select your goal as ITJ, and click on that get subscription button. Right. And when you're redirected to the payment page, don't forget to use the code RDLive. And when you click on proceed to pay, don't forget to use a lot of no cost EMI options that can ease this payment also. And now you can also go for the Iconic subscription. So Iconic subscription will take your ITJ preparation, of course, to the next level. You will be assigned personal coaches, and you'll be able to attend a lot of ITJ workshops, receive expert guidelines, get a study planner, and regular test analysis sessions. Okay. And if you want to win yourself the Unacademy subscription, this is one way of doing it. You can take part in the Unacademy Combat, which will happen live on the 20th of December. You can enroll now in that using the code RD Live. Do well in that and win yourself not only the Unacademy subscription, but a lot of cool prizes, by the way. So Somil Garg says, sir, these questions are for JEE Advanced. So yes, Somil, yes. These questions are for advanced as well as Olympiads also. Some questions are more relevant to Olympiads, but most of the questions are relevant to Olympiad and advanced both. Okay. I mean, you can figure out that for yourself, right? You can see the solutions and you will realize these are the kind of questions that advanced also likes asking, right? Kamil. Okay. I hope that answers your query. Next, a very important announcement for all class 10 students. So there is going to be a class 10 boot camp for all those who are trying to prepare for JEE 2023. So that boot camp is going to happen from the 13th of December to the 19th of December. So all class 10 students can join this camp, get a flavor of how it is going to be when you are preparing for your ITJ exam. Sir, laptop bhi milega. Yes. Laptop bhi hai. That is also one of the prizes, of course. Again, so if you like today's session, don't forget to hit that like button. Okay. So trust me, that is all the encouragement that we get. Unacademy is trying to provide you such quality content absolutely free of cost. The least you can do is support us back by hitting that like button and sharing with more and more students who might need this quality content absolutely for free. If you're new to this channel, don't forget to click on that subscribe button. And again, you can also click on the bell icon to keep receiving notifications of amazing sessions and lectures happening on this channel. In the PDF of all the slides used, again, I don't think you will be needing that because you can watch the solution anytime that you feel like, right? Next, if you are following us on the JEE English channel, then here is another way to stay connected and make sure you're not missing out on any of the sessions happening here. You can connect with us on the Telegram app using that link. Okay, there, right there. So that will make sure that you are receiving all timely notifications, because a lot of times students complain that they don't receive timely notifications from YouTube. So you can join that Telegram group and make sure you're not missing out on anything amazing going on here. Right, so that is my time for today. Before I say goodbye, let me remind you one last time, this is my code RD Live. So if you like my lectures, if you'd like to enroll in my courses on the Unacademy Plus, you can get your Unacademy subscriptions using this code. This will also give you a cool 10% off on all subscriptions. All right, so that's it from my side. I will see you next week with this session again, and I will bring in more problems apart from Pathfinder, because I think I myself have a very good collection of problems on rotation for advanced, especially. Okay, so Somil, don't worry, you can come join this session live in next Saturday, and we'll be going over some really tough, challenging problems, which will be very good practice for advance. Okay, so that is it from my side. I will see you next week. Then till then, you guys keep studying hard and keep practicing. No time to be slack. Okay. So till then, you guys take care of yourselves. Bye bye and good night.